Assalamu alaikum. This is the suggested modified design for the 4 bar open and cross loop mechanism apparatus design. Uh, this was actually reported some students while in the class today that they are finding difficulty in fabricating the previously suggested design for the same mechanism. So I have devised and suggested this new design, and students also requested that I will be showing this video by rotating. So here we can rotate and show like this, and as we can observe basically that in this design there are used 4 identical rockers. These 2 rockers which have been shown on the background behind these 2 protractors, these are actually auxiliary or assistive uh, rockers, and actually uh, these 2 rockers are actually making a parallelogram linkage, and this this is actually a parallelogram linkage between these 2 nodes and these 2 rockers. And as we can observe on the back end that here are 2 holes in the protector frame, and the distance between these holes and these holes is same, and these 2 holes will be in the protectors frames, and these are 2 identical protectors, and they are actually translating. So a separate protector frame can be designed or specified, or we can use physical protectors. But remember that it is very important that uh, as we see it's in the front view that this center point of these protectors must be coincident with the center of this node, these joints. So student which are often making mistake that they are placing these protectors somewhat away or just pasting or fixing it anywhere. Remember that if you have physical protectors or frame, you will be creating a node or hole that will be concentric with these nodes, so that the center of the protector is coincident with the nodes of these protectors in a similar manner here. So these are 2 translating protectors, and remember another apparatus with the title to measure the transmission angles. The same mechanism was designed for that apparatus as well. So a same kind of apparatus and suggestion has been made for this open and cross loop mechanism. So this is the open loop, and this is the cross loop, and how the angles will be measured in one way. I suggest that if we study from the book, actually this is the reference diagram. This is the reference diagram, and as we can observe that this is actually the theta 4 for the open loop. This is the theta 4 1 actually for the open loop, while we see another diagram here. This is the theta 4 1, actually this is for the open loop, and This is actually theta 4 dash or theta 4 subscript 2 is for the cross loop, and in a similar manner this is theta 3 1 for the open loop for the coupler or connecting rod link, and another angle which will be started from here and that will be covering up to this link, so that will be theta 3 2 for the cross link coupler link. So in this way there will be four angles, two for the rockers, one for the open and for the closed location of the rocker, and one angle for the coupler link for the open loop and another one for the cross loop, and this is the input angle which will be varying. So input will be given to the crank. So in this way, as we can again rotate the video and observe like this, that in this way the mechanism has been made very carefully, and we also note that elevation is very important. As we can see here, there is some gap. This is the gap between these links. Actually some spacers or washers will be used here by the students. They will be actually fabricating this apparatus and they will be filling these spaces so they can create the correct elevation, and this is just a guidance and a brief overview of the design. So how this apparatus will be moving, I will be showing it in the video mode, but before that I will be showing how when the apparatus will be working, how the angles will be measured. So as we can see here that this is the theta 3 1 and that theta 3 2 here, and theta 3 2 here will be actually this the angle of this straight line will be 180 degrees. So 180 degrees will be added with the angle, that angle will be made here with this negative axis up to this link here. In a similar manner, theta 4 actually starting from the positive x-axis anti-clockwise according to the equations derived. So we will actually be requiring only this angle, so 180 will be added into this angle. This only we will be requiring this sweep only, so the angle will be calculated. And here we can see that if we look at the apparatus in the front view, that here for example this is the theta 3, this is the theta 3 at this time. So as we can observe, the angle between this horizontal line and this white dim calibration line, the angle will be same. So at this stage I can say, for example, the angle here is about 50 degrees. So in this way, when the crank is at 0 degree, so the angle for the open loop at this stage is 50 degrees. So in this way angle will be measured, because this angle and this angle, these two angles are same, these are two alternate angles. In a similar manner, theta 4 1 actually in the derivation or in the book, as we can see here, this is theta 4, and that will be actually measured between this 0 and 180 degree horizontal line of the protractor and between this calibration line, because this complete angle and this angle will be same. And for the cross loop, as we can see here, that we will only be requiring between this horizontal line, which is we can say along the negative x-axis, up to this link. So the angle between this white dim calibration line and this horizontal line will be same. So we will be uh, measuring this angle. For example, as we can see, for example, if we are noting from the internal calibration here 90 and here 120, and somewhat here as we can see the calibration is on 130-degree line in the clock counterclockwise orientation. So 180 will be added into this 130 further, so the angle from here anti-clockwise up to this link will be counted. So in this way, while the protectors will be, remember these two protectors are in curvilinear translation, and a similar mechanism is used in our automobiles or cars, wipers mechanism. And third one protector frame that will be used here, or physical protector can be used, that will be behind the crank. Remember that proper elevation of the links and location is very necessary, so that none of the link actually interferes with any other link or merges into each other for smooth working. So now I will be playing this video in the front view mode. So I can say here that in this way the video will be placed, video will be playing. In this way. So while the video will be playing, I can also show it by rotating, that how it will be actually working like this. Uh, so in this way the video will be the apparatus will be practically or physically operating when once it will be prepared. And remember that students are required or preferred that they will be creating this open and cross loop all links using some transparent or acrylic material. So this is very important. So, and they will also be creating some dim marking lines that will be connecting center to center these nodes, so that they will be actually helping to note the readings from the translating protectors. So in this way I have suggested the modified design. If you have still any confusion or difficulty, you can frankly ask by personally meeting while in campus, or you can positively comment here. Remember the word positively, that you will always be commenting if you have any difficulty. So thanks for listening and tolerating. Jazakallah. Assalamu alaikum.